All right, so my name's John Kindervog. I work for Ontoit. If you weren't here yesterday, you don't get that joke. So we're going to talk about powering Zero Trust. So what we got from SEI was basically this document. This document says, these are the things that we want you to answer. And like any other document, there's always a lot of stuff that you kind of have to read through, and then there's things that you should walk away with. So let's start with this first proposition of services with global users. Okay, people are everywhere. How do those global users connect to whatever system they're going to get to? They're going to run across the internet. So that means we've got to cross the battlefield. Let's keep that in mind. Hybrid multi-cloud enterprise. Great. Everybody's hybrid, everybody's multi-cloud. Makes a lot of sense. 15,000. Not really concerned about the scale of the users there. Lots of users, lots of stuff. We can deal with that later. Contractors is what concerns me the most. Why? Because contractors do different things than my employees. I cannot enforce a lot of stuff on contractors that I can on employees. So we have to have a way to deal with that. We have to basically make sure the contractors subscribe to our model in order to connect to our system. Otherwise, they can't get to the network. IT, OT, SCADA, really, that's not as complex a problem as we typically think about. Why? Because what should an IT, OT, or SCADA system do? If it's a thermostat, it should do thermostat stuff. If it's not doing thermostat stuff, guess what? That's a problem. If it's a SCADA system, it should do SCADA stuff. If it's not doing SCADA things, guess what? That's a problem. So we can begin to remediate, isolate, and control those systems. Legacy systems in one database, not a big deal. The real problem there is that the data that it contains. That's literally said right there, that's our crown jewel. That's the stuff we're most concerned about, PII in this case. We have to deal with that. Legacy systems means it's old. Legacy means I can't put a lot of things on it because it'll fall over. We need to basically be able to get in front of that legacy system and have a means of control to whatever's back there that we call legacy. Two-factor MFA, given. Two-factor MFA, those types of things have to be employed, have to be put in place all day, every day. And then lastly down here, and I'll show this at the end of this, is our budget. Our budget's $3 million. $3 million sounds like a lot of money. Those of us in the IT space know $3 million goes by really, really quickly. So we've got to be able to work with technology that enables that particular approach that doesn't require us to bill until we hit $2,999,099. OMB came out and they said this is the big crux of the whole thing. This is what we should take away. We need to accelerate agencies toward a shared baseline of early zero trust maturity. In other words, thou shalt not wake up on Tuesday and be zero trusty. We need to push organizations to move towards a zero trust implementation, and we need to establish what maturity looks like so that we can figure out where we're going. Perimeter-based defenses to protect critical systems and data cannot be implemented. We are not going to live in that model anymore. We must move past the old model where the perimeter is a thing. We should not have perimeters. Perimeters are just part of the equation, but perimeters are now transitory. They are just as ethereal as everything else in the space. Secure access applications over the public internet. This is probably the most twisted thing in this whole piece that we've gotten, is how do I take my applications, my users, all that stuff, put them on the internet, which we have said is an inherently threatening, compromised combat environment, and keep them safe. In other words, if we do the same stuff, we will fail because that environment literally runs antithetical to what we're trying to do here. And encrypting DNS HTTP traffic with TLS 1.3. I can't do that stuff out on the internet because it is the internet and it's wild and I don't control it. However, there are ways that I can put things in place that will mandate if you're going to get to my system, if you're going to connect, you're going to move around, this will be in place. In Dominus Patria Filisantes, let it be written. ZT is not a product. We've talked about that repeatedly, but products do power strategy, right? I want to move from this CIA, which confidentiality, integrity, availability thing, which is interesting, but I would put that in front of people, and I think this is a good talking point, that CIA comes after this other model, which I think is more applicable on the compromised side of the internet, which is RTA, and I'll tell you what that is in a second. By the way, part of this thing was we were supposed to have some thought leadership-y type stuff, so this is where I'm doing a little thought leadership-y type stuff. The strategy goals overall. Identities. I want to secure them and use them. I don't care what the identity is, but I want to have a way of securing it, and I want to leverage that identity. It's going to be the fulcrum that's going to make this stuff work. Devices. Everyone's moving to BYOD. I think we've heard that a lot. We talked about how Corona has proven that this is a way that we can do work. Nobody necessarily wants to come to the office 5 days a week anymore, even in the federal space. We have people right now in the federal space that are doing classified work on stations that are no longer inside of classified buildings. So we need to be able to push controls out there and enable that type of capability because they're not coming back to work. I think the last study I saw said 33% of the global workforce will never be 5 days in an office again. That's pretty staggering. Networks, unclassed network anywhere, honestly, it's network agnostic. The way that we need to move to this model is I don't care what the network is, I don't care where the network lives, it's Comcast, it's Amazon, it's whoever else. I'm just gonna use that to ship packets, but the packets are gonna be doing the right things because I have command and control of where those packets go, what they access, and how they're used. Applications and workloads overall, let legacy live. There's been a lot of talk about killing off legacy, moving it to the cloud, whatever. There are systems, especially in federal and banking systems, whatever else, we cannot move them to this new digital side. I did a workshop with the Library of Congress that still has punch card stuff running. How in God's name are we going to digitize that and move it to the cloud? We're not, it's going to stay there, it's going to be there because it's been there since the dawn of time. Enable the future of work, take care of the back end, and again, remain cloud agnostic at all times. Data, which I didn't hear a lot of people talk about over the last few days, is the key thing, right? That's the Willie Sutton piece. Why do people break into banks? Because that's where the money is. If we're going to take care of anything, it's got to be taking care of the data. For the users, I'm sorry, user, it sucks for you that you got pwned. I'll get back to you, I'll fix your machine later. If they can't get to my data, if they can't take the OMB database, you had a bad day, I'm not on the cover of CNN. Policy-driven access and secure in transit at rest. That's got to be part of the protocol, it's got to be part of the exchange, it's got to be mandated. And then users, notice I put a difference in here between identities and users. When I created the ZTX ecosystem, I didn't even come up with something for identities, it was users. However, everything has an identity, not everything is necessarily a user. Let them work anywhere securely, on any device, on any network. Oh, and by the way, I'm not gonna worry about phishing. I'll talk to you about how we get past that problem. Does anyone here like taking phishing training? Please raise your hand, because you're lying. All right. We have known for a long time that the perimeter-based model of security was going to fail. We have known since 1260 BC, a long time. What happened in 1260 BC? Anyone want to throw that out there? The fall of Troy, right? 1260, 1280 BC. What happened in the Trojan War? Why did Troy fall? They had beat them, they had won, the bad guys were out. They saw this cool looking horse outside. They said, oh, we should bring that in and have a celebration. Didn't know there was a bunch of bad guys inside. What did they do? They dropped out the Trojan horse. What do we used to call malware? Trojans, right? They brought them past the wall, they dropped out, they moved laterally, burned the place to the ground. You wind up with a terrible movie with Brad Pitt in it. We have known for a long time that this model of security fundamentally, categorically did not work. We took it into a digital space that required us to move in and out of walls, and we said we think we got it fixed. Doesn't make a lot of sense. This is why ZT makes sense. This is why this is applicable. This is what we should have been doing since day one. So we have known for 1,000 years that this was never going to work. We've talked a lot over the last couple days about the definition of ZT. I'm not going to go through the definition again because we've all said that enough, and I think somewhere every time you say it now a kitten dies. But really what we're getting into is we're denying access to applications and data. Period, point blank, end of story, by default. Granting access to networks and workloads utilizing policy-informed by continuous contextual risk-based verification across users and their associated devices. 800-207 tells us that we have to do these things as well. All data and sources and computing services are contended resources. Okay, great, that's the future of work. That's how we're going to work, that's how we're going to live, that's how we should look at the infrastructure. All communication is secured regardless of the network location. I don't care, literally 800-207 is telling us, I don't care what the network is. You're gonna use Comcast, you're gonna use AWS, you're gonna be at Google, Starbucks, whatever else, that's BYOD. So we have to be able to secure devices and take care of those assets. Access individual enterprise resources granted on a per session basis. What does that mean? Time horizon. You get access, 8 hours later, you're not at work anymore, your access is killed. Tomorrow you can do here the cool things, authenticate, et cetera, you get to the resource. You don't get to it all day long every day because that's only good for the Chinese and the Russians. Access to resources determined by dynamic policy, including the observable state of client identity application service requesting asset, and may include other behavioral and environmental attributes. What does that mean? Policy must be fed by machine learning. Notice I didn't say artificial intelligence because artificial intelligence only works for Elon and it's not a real thing. Machine learning and mathematics is what we're talking about here. That feeds policy. Enterprise monitors and measures the integrity and security posture of all owned and associated assets. What does that mean? We got to take care of devices and asset integration. All assets, all devices should be considered part of our network. However, we have to understand We don't own them. They live where they're going to live. Resource authentication authorization are dynamic and strictly enforced before access is allowed. Identity and access management has to be tied into policy. I'll show you how this works in a second. The enterprise collects as much information as possible. This is the logging stuff that we saw in the RFI. We want logs because of the logs, because there's logs so that we can log stuff. About the current state of assets, network infrastructure, and communications, and used to improve its security posture. What does that mean? Lots of logs. Logs equals telemetry. Telemetry feeds policy. Policy applies all those other things. If we can do this, we are enabling zero trust principles in line with NIST 800-207. Sounds really complicated. No one can actually do this. Maybe not. I think that this is a fundamental flaw in where we position ourselves as far as security globally, right? CIA, confidentiality, integrity, and availability. Are any of the systems that we've dealt with in the past that have been pwned, did they not have confidentiality, integrity, and availability as part of that matrix? It was there. Systems were confidential, they thought. There was integrity, availability, that was it. Did that equal security? Not really. I think the model that we're moving to, honestly, over time is what this looks like, which is risk, trust, and access actually equals zero trust. We heard everybody in here over the last couple of days talk about reduction of risk, manageability of risk, taking control of risk, those types of things, and applying it to all things. Users, identity, access, network, all that stuff, right? So if we can manage risk, we're doing better than confidentiality. If we can take care of trust, trust is an inherent flaw and a vulnerability in the system. Trust is something humans do. Trust is not something that computers do. We must remove trust so that we can get towards zero. And again, like we said, we'll never be zero, but we're going to be manageable. And lastly, what's the thing that allows risk to increase and makes trust actually more vulnerable? If we allow access to take place across the system. So if we can move to this model instead of relying on confidentiality, integrity, and availability, we are enabling ZT, which ultimately, when that system is zero trustee, you can have your CIA on individual systems. So this is my thought leadership-y type thing. Maybe I'm way wrong, I don't know. I think this applies in the broader context of future state for zero trust. There's things that we can do and things that we have to take as a given from government systems. When we look at NIST 800-207, we look at those types of things. Does the government not have threat intelligence? I sure as heck hope so. They get lots of threat information, right? They get lots of intel. Does the government not log everything all the time? No, they do. We have acres of servers and software that do nothing but logging. Who wants to do PKI? Nobody. Not even the PKI people want to do PKI anymore. That's a given. It's there. CDM, government has CDM. Really, where we have to sit, the sweet spot, is enabling the policy type, being able to apply controls, and figure out where we're going to enforce that policy. Now, what they got wrong with this particular implementation was that we need to apply that policy, the policy enforcement point, further out than just to that system. It needs to go out to the internet, to the web, in front of the user, in front of the identity, on that compromised battle space. If we do that, we are pushing that control plane all the way out to the wilds of the internet. We become a much harder system. And oh, by the way, we're not worried about phishing anymore, because people can't get phished if they can't interact with malicious content. Very basically, this is what we're trying to do. This is what we're trying to do all the time, everywhere, for every instance. This is the model that makes the most sense over the course of evolving to ZT. Verify explicitly all things all the time. Read through 800-207, read through the RFI, read through those things. It's not mentioned specifically, but this is what we're actually doing, verify. When I say never trust, always verify, verify explicitly all the time. Always employing least access privilege makes a lot of sense. Why would I allow someone to do things they shouldn't do? Need to have command and control over that. And assuming breach. Everything is compromised. You're compromised. I'm compromised. My machine is compromised. My network is compromised. My data is compromised. That asset is compromised. It's compromised until it's proven that it's not compromised. The session is allowed, and then guess what? It goes right back to that state of untrusted again. It's not verify, least privilege. You're okay. You're compromised. This really looks like this. ZT, in broad strokes, looks like any entity can ultimately get to some resource. How you get there doesn't necessarily matter that much. That entity could be me, it could be a machine, it could be a thermostat, it could be a robot, it could be a Tesla, whatever. Somehow or another, some entity is going to get to a resource. We call them applications. How do you do that? In this case, it's a person. I'm here right now. We've got folks that are on Zoom. We've got folks that are working from home. They're a person on a device to get to a resource, right? Until Elon figures out how to embed us with those whatevers, we're going to be using a device to get to a resource. How do they do that? They run over some network. You don't own that network. I don't own that network. The network may be dispersed, displaced, whatever. It could be Starbucks. It could be Telstar or Starlink or whatever they call that thing or whatever. It's going to move that way. Where are the controls actually employed? Right there. That's where they go. And those things are applied across the entirety of that infrastructure at all times with validated telemetry that makes that possible. You take in context whether or not this should occur, and you apply a control. And you can go up and you can go down. But that's the sweet spot. That's what they're trying to get to. And ultimately, the further out you're able to push that policy to that user, that entity, that identity on the internet, the further out your control plane goes. It's too late if I wait for my user to be safe and secure. They're going to get compromised, right? I think it was 90-something% of all compromises occur by people clicking malicious content on the internet, even though we have multi-billion-dollar a year training programs. Let's push that control plane way out. Ultimately, what we want to do, determine the HVAs and the associated data. What does that mean? Data security. Data security wasn't talked about a lot. Data security is why we're ultimately in cybersecurity anyway. That's where the money is. We need to inventory the assets, accesses, and control points. We heard that a lot. We got to know what's going on. We got to know the baseline. We have to be able to have visibility in those systems. This really means inventory, asset interception, knowing what's going on, being able to get telemetry, logging, and see the system. Plot control strategy, all the things. What is my strategy for securing all those things? Because as we establish that baseline, this is going to get quicker, better, faster, and more complicated. We've talked about complexity being the enemy of good security. If we don't continually establish the strategy and make sure that we're driving that as far down the stack as we can, it gets really complicated really fast. Segmentation all day, every day. Segment the data, segment the device, segment the workloads, segment the users, segment the network. Vectoring the policy to enable that segmentation, and then make sure that you do this repeatedly, right? This is not a one and done, continuous validation and updating, testing the system. In order to do that, there's a layer of the model that ultimately I think a lot of us have forgotten about, which is that entity layer. Applications are applications. Presentation that this is the OSI model pretty simply, but really we have to take care of that thing that's going to interact with malicious accesses, content, and those things as far out as we possibly can. Otherwise, we're trying to defend Troy with the door partially open while the bad guys are standing there knocking, waiting to come in. What is required? Role-based access control, identity access management, and I would postulate you're also required to use remote browser isolation to enable this particular piece of this. Why? Managing users. How many folks are on the internet right now? How are you accessing the internet? You're using a browser. Where are you going to interact with malicious content? Via that browser. Why would I not put a control in front of you on the very thing that I know you were going to use to interact with the malicious content that would cause an infection? Doesn't that seem kind of like ignoring a very, very large threat vector? If you said 5 years ago, was RBI a good technology, I'd have told you no, it was hot trash. Now RBI is a really good piece of technology. We have to use device integration and web application isolation. I did not say WAF. Why? Because 87% of WAFs, according to the Ponemon Research Institute, are in monitor-only mode. Why? Because they don't actually defend much. They make lots of alerts, and they see lots of stuff coming, and then they don't really fix the problem. Web application isolation is taking that capability, kind of flipping on its head and saying, here's a policy control, put it on this particular thing in front of an application, and then I don't worry about what the device is doing. If it does not meet these policy control levels, it does not access my application. Encryption, segmentation, isolation, dynamic data security. The problem is, how do you do this all at speed and scale? It's doable, but you have to be these things. You have to be cloud agnostic. I don't care what cloud you run on. Cloud is the cloud is the cloud. Great, use it, that's what it's for. MSSP optimized, why? Because just like in the RFI, you might not have a SOC, or your SOC might be really bad. So you're going to need someone else to help you do this quicker, better, faster. You outsource, you bring SOC providers in. So you need to be able to enable them to do their work. Agent-based or agent-less, why? because a lot of times I can't put an agent on a machine. People will say, no, thou shalt not put agents on my machine. There are requirements from organizations say no agents. If I can flip that model and I can run agentless, great. Pick your poison. How do you want it? Keep the user secure on the internet. That's where compromises occur. I want to keep them safe. Policy driven with ML. The ML's got to work. I can show you how that actually works in a second. Device integration control, moving from old legacy networking to new legacy networking. I'm not talking about moving those legacy applications. Those can do what they're doing, but we're moving towards these new types of networking. Secure remote desktop. Why do we need secure remote desktop? When you look at the contractor problem, what are contractors typically doing inside of systems? Administration. Why would you allow an administrator on a system to get to you that you don't necessarily own when you could put a control in front of them that says, this is session-based, VDI, et cetera, et cetera. Hey, contractor, you're gonna do admin, you're gonna do it via this channel. You're not taking your thing and VPNing it to my box with your infection. I don't want your dirty laundry in my hamper. Data discovery redaction based on roles. This is the dynamic data side of it. Taking care of virtual meetings. This was something that we also didn't have a lot of people talk about. How do you do business nowadays? How many folks have been on the Zoom call this week? Can I not drop you a phishing link in a Zoom call? Can I not drop you a phishing link in a Teams call? You need to be able to secure that. Otherwise, you are not enabling future of work, and I can't do BYOD. Problem. API integrated, I don't care what other cool technologies you have. If you love Cisco, by all means keep Cisco. But guess what? Cisco's got these crazy cool things called APIs. I can hook into that and use it to enable a control based on something coming across the ML side. And then make sure that IAM, 2FA, MFA, et cetera, is there. The policy itself is machine learning driven. Say that 3 times fast. Machine learning driven. Basically, what you're talking about is a unique personalized policy is created for each user or application, because applications access other things as well. Users access different applications certain ways. The policy builder observes the application's usage, automatically created for each user based on what they're doing, and then manually adopted, manually changed. The great thing is if you employ this correctly, you wind up with a really quick default deny policy that's based on how users and applications actually do something in the context of work. You click default deny, everything else goes away. You know how you know you got it wrong? When they send you a ticket. I need to access this thing. Okay, great, I'll fix that. You can go access that one thing. Instead of someone having access to hundreds of applications because they have some nebulous need, you can actually see which users are doing what to get to which application. On top of that, at the end of it, using machine learning the correct way, you can actually tie in which users on which networks, using which devices get to which applications and which data they're actually getting to, and then you can begin to pull that data back based on that policy control. To keep the users secure on the internet, it's this, right? You work anywhere, your device, BYOD, whatever, I don't care. I'm gonna put this thing in front of your browser's gonna be running inside of a container in the cloud. You try and click on malicious stuff. We know what malicious stuff looks like. If it's an iframe redirect, a Java drop, whatever else, it doesn't work, you get a little alert and go away. If you're not supposed to be accessing certain things, it's just not available to you. This works really well when you're talking about IoT, OT, and healthcare systems. Why should a X-ray machine have web-enabled access to Playboy? They do. Wouldn't it be smart just to say, what's the only domain that that machine needs to get to? Great, it goes there. Everything else on the internet is unavailable to it. Problem solved. Well, how are they going to access that thing? A browser. So apply a control there. Data, using that machine learning approach, is discovered within that context as it's actually accessed. And again, you're continually refining that policy, which user on which device, on which network, on which application get to which data. You run that for, say, 3, 5, 7 days. You'll see what looks right. You remove all the other stuff. Because of the dynamic nature of controls, you can say, you should be accessing this thing within that data structure. You should only see email addresses. Great, well, inside of that data repository, I have all that PII. You only need email addresses. I can validate that that's what's right. The only thing that will ever be visible to you is email addresses. And how are you going to access that information? Via a browser. The rules build themselves, PII protection, third-party access, et cetera, et cetera. And I can even tell you the data types that are protected, and then whether or not the rule is active, redacted, et cetera, but you're doing this with machine learning, policy-based controls, all the way down to the data level. And the rules should be written in these systems in regular old plain English. Nobody, like General Tuhill was saying, nobody needs to take an 18-month certification and learn how to write a regex. Right? You should be able to write this in plain English. This user should not see this data inside of this system, push the control, go on about your day, go do your work. Everything is validated via any IAM solution. This is where APIs come into this again. The goal of a good technology solution is not to say that I am the only thing that you can use. The goal of a good technology solution is to say, you've got stuff you like. Maybe it's Microsoft Authenticator, maybe it's Google, maybe it's Okta, maybe it's Duo, maybe it's whatever. Great, hook in, do the validation, apply a control, go on about your day. There's other things that I can do. I can help you translate that within the context of these other pieces of the network, but ultimately, use whatever you want to use. If you can't use that, there's a system that's available for you. The web application side, like I said, I know that in a BYOD world, how am I doing on time? I got like a few minutes left. Okay. In a BYOD world, I know that I can't secure everybody's device. UEM, it's really hard to do. You have to push stuff out. You've got to have agents, whatever else. If I flip the model a bit and I say I'm going to put a policy control in front of the application, and if your device does not meet those policy controls, you can't get to the application, I don't have to have UEM on you anymore. It's a policy control in front of the application, therefore you can't get to it. You go back and get an alert that says you need to update your iOS so that you can get access to my app. Go update your iOS, you get access to my app. No more management of the device. Secure remote administration stuff is really great because what is the #1 avenue of compromise for people on the internet to get towards protected systems on the back end? RDP, 3389. If I want to take that and I'm going to cloak those systems, which we've heard a lot about cloaking those systems so that they can't see them, the folks that should be able to see them, that should be able to do the work, have to have some means of getting to that access, but it doesn't need to expose itself to the internet. I can't open that port, is what I'm saying. So if I'm able to use this policy type of control and say, look, you need to do RDP work, administrator, I've got your IAM taken care of, I've got the network side of it, I've got everything else in place, you can get to it, but I'm only going to pipe you to that. Oh, and by the way, it's running in the context of this session-based virtual instance. Everything is much safer. The network is cloud agnostic, doesn't matter as long as you're putting controllers in the right place, and this is very similar to the majority of the rest of the models that were talked about here during the rest of the week. As long as I can put some type of virtual controller out there, I can port traffic where it needs to go so that I have command and control that infrastructure. The command and control that infrastructure goes back to the ML model that feeds the policy engine, which therefore is applied across the entirety of the infrastructure. If I do these things, I'm enabling zero trust, right? And the great thing is, if you're doing this correctly, because of the power of machine learning, because of the power of mathematics, cloud, all those things, it gets better over time instead of getting worse. If I'm whittling away stuff, it gets more refined. You will see very quickly what is necessary, what is being used. Anything that is not necessary or being used is a risk, therefore must go away. If I reduce the risk, I limit the trust, and the access becomes safer. So ultimately, if we approach it in this particular manner with these other controls thrown into the mix and enable it with this model, you get to this place that you're trying to go to, where you're securing the services. I don't care if you're hybrid or multi-cloud. I've taken care of your contractors. As far as the IoT, SCADA, OT side of it goes, it's a pretty binary problem. The legacy database is taken care of because we figured out how to control the data, make sure that only these users can only see this data only for the purpose of this transaction and only in this manner. Access management system, use whatever you want to use. Legacy stays legacy. We're putting things in front of those legacy applications so that we have a policy control in front of it, not affecting that old legacy system. Keep your punch card thing back there that you've had since 1953. We'll just sit in front of it and take care of it. Not worried about the SOC because this is MSSP enabled, this is MSSP focused, because it says right here in the RFI, SOC operators are broken, it doesn't work very well, great, let's outsource this, let's bring somebody in that this is what they do. Or at the very least, take your sort of broken SOC and find people that aren't so broken and make them work together, and all of a sudden the SOC becomes optimized. Two-factor, multi-factor, it's a given. And then lastly, the $3 million in the 1-year timeline. Because of the nature of the system that I'm talking about, the proposal that I'm putting up here, I can tell you, if you say you've got 3 million, I can do it for 1.5 because this is all cloud, all software, and doesn't require services. it learns on its own and then it's applied on its own. So whatever the price model is, baseline will be 50% of the actual proposition. So what we're doing is we're optimizing, we're solving for that business case because the business says you got $3 million in 1 year. So I've got to be under that. I'm not going to be $2,909,099. I'm going to be way less than that. And I'm going to make sure that I'm using technology correctly to employ those controls to work so that timeline gets exponentially reduced. As far as how fast this happens, I'm a big fan of the approach that's been suggested by mentors of mine. Start small, think fast, or start small, think big, scale fast, right? That's what we want to get to. You can't do that with people. You have to do that with machine learning, with mathematics, with those type of capabilities. Therefore, start small, start with 50 users, 100 users, something like that, 5 applications, and then begin to grow from there. But the more you do it, because of the power, again, of mathematics and machine learning, the quicker, better, faster you get to that end state. There, 21 minutes. I can breathe now.
Now you have 10 minutes of questions.
No, I'm John Kindervag. Send all questions to John Kindervag. John Kindervag at ontoit something or another. Yeah. No, if you have questions, please ask them.
I'm on the line.
Okay, cool. They probably all turned me off.
Yeah.
All right, cool. Then I did really good.
Thank you very much.
Yep.